Hey guys, welcome to the Hannah Lab. pH affects a lot of things, and it's important to feel confident when measuring it. We know everybody makes mistakes, but not everybody knows when they're making them. We're going to take you through some common mistakes people make when conditioning, calibrating, and using a pH electrode, and show you some best practices to prevent these mistakes so you can feel confident in your measurements. Remember, the best results come from the best practices. Number 10 on the list, using a deteriorating electrode. Just like any piece of equipment, pH electrodes need to be replaced from time to time as part of regular maintenance. It's good practice to replace your electrode annually. Number 9, inadequate probe submersion. pH electrodes are built with a junction near the bottom of the glass. When measuring a sample, that junction needs to be covered by the sample, along with the electrode bulb. If the junction is left uncovered, you will not only be measuring your sample, but measuring the air around it too. All you need to do is make sure you have enough solution to cover the junction to give you the most accurate readings. Number 8 on the list is one that not many people notice. The electrolyte in your electrode is not filled to the proper level. Inside refillable pH electrodes are electrolyte solutions made for completing an electrical circuit between the sample and the electrode. This is how you get your readings. If the electrolyte is not filled, the electrode will not be able to obtain a stable reading. Electrolyte solution should be filled to 1/2 inch below the fill hole. Before we take a look at number 7, let's talk about how the correct flow of electrolyte produces faster and more accurate readings. Refillable electrodes are equipped with a fill hole cap. This cap serves two main purposes. First, it's useful in keeping your electrolyte solution from leaching out of your electrode when not in use. And second, when you are using your electrode, you can open it to increase electrolyte flow. Number 7 on the list is not loosening the fill hole cap. Keeping the cap tightened creates a pressure difference. Refillable electrodes work best when the electrolyte flows through the junction. Number 6, choosing the wrong electrode for your application. There are literally thousands of different types of samples. Whether you're measuring the pH of your soil, or dairy, or food products, you always want to make sure you're using the proper type of electrode. If you're not sure what the right electrode is for your sample, you can always reach us at sales@hannahints.com. Our professional staff can direct you in the right direction for all your measurement needs. We're now at the halfway point. pH mistake number 5, calibration errors. If you're worried about the condition of your electrode, you can always check the electrode slope and offset. To do this, you need a meter that reads millivolts and pH 4.01 and 7.01 buffers. The millivolt reading of your pH 7.01 buffer is your offset. To check your slope, take the millivolt reading of your pH 4.01 buffer, subtract your offset reading, and divide by 3. Divide that answer by 59.16 and multiply by 100. This is your slope percentage. If your slope is 85 to 105% and the offset is plus or minus 30 millivolts, you're good to go. That brings us to number 4, not cleaning the electrode. It doesn't take long for the electrode glass to form a dirty buildup. This buildup creates a barrier between the glass and the sample, causing readings to be inaccurate. Cleaning with distilled water alone will not remove the coating of some organic or inorganic materials. What you need is cleaning solution. Immerse your electrode in cleaning solution for 10 to 15 minutes before storing it away. After you've cleaned your electrode, keep the electrode capped in storage solution when not in use. We've come this far, and now it's time for our top 3 pH mistakes. Number 3 on our list is a common mistake, storing your electrode in distilled water. It is best practice to rinse your electrode with distilled water before using your cleaning solution and storing it in storage solution. But if you leave the electrode in pure water for too long, it will dilute the reference electrolyte. Diluted electrolyte causes inaccurate readings. So, like we've already said, when storing your electrode, be sure to use electrode storage solution. This will keep your electrode conditioned and working properly for much longer. Number 2 is also a very common mistake, wiping the sensing glass. As we've already discussed, electrode bulbs are made from sensitive layers of glass. Wiping the electrode wears on these layers and creates a static charge that interferes with the voltage reading of your electrode, giving you wrong readings. To clean the electrode, rinse it in distilled water. Well, we've come a long way to get here. To recap, we discussed using a deteriorating electrode, inadequate probe submersion, low electrolyte fill levels, not loosening the fill hole cap, choosing the wrong electrode for your application, calibration errors, not cleaning the electrode, storing electrodes in pure distilled water, and wiping the sensing glass. These 9 mistakes happen to someone, somewhere, every day. Number 1 is no different, and it happens more often than you might think. Our top pH mistake coming in at number 1, storing electrodes dry. Have you ever done this? The buildup of salt on the electrode can get pretty frustrating, and you may not even know what's going on. This buildup coats the sensing glass, and eventually the glass becomes dry, slow to respond, and unstable. It takes a while to bring your electrode back to working order if it has been stored dry for a long time. But don't worry, there is a way to keep your electrode working. First, rinse your electrode until it is clean. Next, place it in storage solution for at least 2 hours. Once you have cleaned and conditioned the electrode, make sure to calibrate and make sure it's working. If not, repeat the steps until you get your accurate readings. So that's it, our top 10 pH mistakes. If you or someone you know are doing any of these things, be sure to refer back to this video or our blog on these mistakes. You can find all the solutions and equipment you need at hannahins.com. Also, don't forget to like this video. Find and like us on Facebook and Instagram, and if you have any questions, you can reach us with #HannahQuestions. Remember, always use best practices when handling your pH electrodes. We'll see you soon.